myself, we both are explaining about this Mathplotlib. Srikar, are you there?
Yeah, sir. Good morning. Good morning to
Yeah.
everyone as well.
Yeah. Okay. Just start the session. Yeah.
All right. I'll just share my screen and let me know if you guys can see it. Am I audible to everyone?
Yes,
Yes,
Shrikar.
you are.
Yes.
Hi.
All right. Wonderful. So, um, yeah, screen is audible, right? Okay. So, firstly, yeah. So, firstly, welcome everyone over here. As you are learning Python, so am I. So, irrespective of how many years you've been working in, programming or in Python or any language, the language is developing every single day. So we're all constantly students. So as I'm here instructing you all at the same time, I'm also learning myself. So before we begin, like if I'm not wrong, you're from the linguistics background, right? Can I ask why you all were interested in learning Python? Like, it's a great initiative, and I just was curious to know, like, why you all had chosen to, explore Python.
Any answer from people? Why you have for
So I'm here to have some knowledge on machine learning as I want to move ahead with computational linguistics. Yeah, and some machine translation.
Okay, that's
Yes.
amazing. Your initiatives are already way ahead of me, so like it's a great start for you. And like I said, it's a great initiative. Python, in fact, in my opinion, at least, is one of the most underrated and at the same time one of the most overpowered tools in the field of engineering or in any field right now. So if you take the field of science and engineering, or even if you take the field of business analytics and MBA, your success in that field is predicated on your ability to ask questions. Like literally anything and everything that you see, it doesn't matter if that's a business model, it doesn't matter if it's a product, if it's a service, or even a single sentence written in English or German or Hindi or Bangla or Tamil or any language. Your success in the field is determined solely on your ability to ask the question, why is it in this particular way? What is it that makes it so unique? Where did it come from? When had it originated? And so on. So the more questions you ask, the more successful you'll be there in the field, because you ask questions, you'll get a sense of direction. You get a sense of direction, you know where to look at and what type of answers you're looking at. So it's solely on asking questions. Up until now, when we had languages like Java, you had C, C++, Matlab, and a whole slew of other languages. Up until now, what used to happen is programming languages were something that all of us used to fear. Like I myself was absolutely terrified of programming languages because I started with Java when I was in ninth standard, and my school was known to be the terror when it came to programming languages and the level of difficulty that they used to set. But then because at that time it was not as simple as Python, there okay, you wanted to add two numbers, you tell a is equal to 10, b is equal to 5, c is equal to a plus b, and then you just got the output. So we had to write around 30-40 lines of code before we could even write that, so that the machine could understand what we are doing. But with languages like Python coming in, what it has done is it has actually taken away all of the stress for us so that we can focus on just the logic and just asking the questions, while the machine takes care of everything else for us. Which is also one of the reasons why, Python is getting so popular these days. Like any and every person is working on Python right now. In fact, this is not an overstatement to actually state that even though I have so many years of experience in programming, and y'all may just be starting out, 1 year down the line, if I study linguistics for 1 year and y'all study programming for 1 year, if you and I apply for a job like natural language processing or something, even under Professor Sri Ganesh, y'all are going to be so overpowered because y'all have such a good fundamental in your background that it's just going, there's not going to be any competition between me and you. The job is all yours. So seriously, kudos to actually, try and get out of your comfort zone and get out of your field, because you all have opened up a huge world of opportunities for each and every one of you all. So firstly, congratulations for that. Coming to Python, I'm guessing you're familiar with functions, libraries, variables, data types, and stuff, right?
Yes.
All
Yes,
right.
we have done that in basic.
All right. All right. Okay. So we'll get started with Matplotlib then. So Matplotlib, as Sir mentioned, similar to Cbone, it is a data visualization library. It's a data visualization tool that is associated with Python, which is a programming language. There is another programming language called MATLAB, which is what Matplotlib tries and looks like. So Matplotlib, along with one or two libraries like NumPy, tries and gives you the feeling of you working on MATLAB. MATLAB, on the other hand, was used for, it can be used for machine learning, but in the electronics field, for instance, it's used for signal processing. It can be used for statistics. It can be used for basic programming as well. But yeah, so Matplotlib was basically created not too long ago. It was created in 2003 by Mr. John Hunter. And it was created as a way so that you could access MATLAB similar type of features using Python. So, and similar to Matplotlib, you have libraries being defined every single day. And it doesn't have to be big companies creating these libraries. If you find something that, okay, you feel that, okay, this is something that people are using day in and day out, and you find an easier way to do a particular task, you can actually create your own functions and libraries and host it online. That's the beauty of a language like Python, where it is open source. So open source basically means that it's free of cost. So anyone and everyone, as long as you know the name of the library, you can just write import and then you put the library name, and anyone across the world can actually use it. So it's encouraging more and more people to jump into the field, which is the reason why this is my favorite programming language. So y'all would have covered Cbone yesterday. Does anyone have any clue what's the difference between Matplotlib or Cbone, or is one better than the other? You all can answer me. I assure you there's no correct answer as such. And I'm a student as well like you, so I won't be judging you all or anything. So like any random guesses, any random answers regarding this?
I had used Cbone once only. So I found that there were options of getting graphs and bars with that.
Correct. So Cbone and Matplotlib, initially when they both started off, they were two very different libraries, but similar to how we get software updates for our phone, all of these libraries like Matplotlib and Cbone, all are like big libraries. So they are getting updates every single month. If I'm not wrong, I think the last update that Matplotlib got was, I think, 17th November or something. So they are growing every single day. So as the years go by, they are actually getting similar and similar. So initially, one of the main factors that used to segregate the two was Cbone was known to have, default themes and default, settings, because of which you wouldn't have to write too many lines of code to actually get a particular look for your graph. Matplotlib, on the other hand, allowed you to customize it a lot. If you had a line chart or a bar chart or anything, you can actually go as far as setting the thickness of the line, whether you want it to be a continuous line or a dash and dotted line or what. So Matplotlib was initially known for its customizability and the heights to which you could customize it. Whereas on the other hand, Cbone was primarily known for being useful for statistics, and that being kind of the way to go if you had to do statistical visualizations and stuff. But at the end of the day, it comes down to your preference. Matplotlib used to be associated with, just basic plotting and stuff. But then the more creative you are, the more stuff you can come up with. Like I've seen people come up with absolutely beautiful visualizations using both the libraries. So that's basically the difference between Matplotlib and Cbone. And I'm sure that as more and more updates come, the bridge between these two will also be, closed, like it'll be closer and closer. And as I mentioned, yeah, so Matplotlib was basically created so that Python could get similar and give you the feel of working with MATLAB. So the commands that you use, the lines of code that you wrote, if anyone's programmed on MATLAB, they'll notice that okay, there's a slight similarity between the two. So PyPlot is basically the module in Matplotlib that I'll be focusing on, which will give you exposure to line charts, bar graphs, scatter plots, and stuff. So, before we go into the coding, there are a few terms that if you familiarize yourself with, it will be very easy. So you can call these terminologies, you can call these jargons, or just basic words that are associated with Matplotlib, and to quite an extent with Cbone as well. So firstly is what's known as the figure or the canvas. So generally when we were in school and we used to draw diagrams and stuff, we used to refer to figure as, in biology, for instance, the diagram, if we drew of the heart, so we used to label it as figure 1.1. Or if we, drew a diagram of a physics diagram, refraction of a lens and everything, we used to call that as a figure. But the term figure is slightly different when it comes to Matplotlib. So if any of y'all is into painting or anything, those big canvases on which people make art, right? So a figure is essentially your blank canvas. So you can either choose to make one large painting on the entire canvas, or you can actually make multiple small ones. It can even go to the extent that you make so many on it that you create somewhat like a photo mosaic, where there are a lot of photos which kind of look like a large photo of its own. So a figure is essentially that window or that pane on which you will draw your plots. Then you have your plots itself. So plots are your individual graphs, like your line chart, bar chart, scatter plot, and so on. So these individual graphs or these individual charts are referred to as plots. So you can have either one or many of those on each canvas or each figure. Then another term you'll be familiar with in some time is a subtitle. So a subtitle is kind of like subtitles in movies, right? Below your screen, in the middle of the screen, you'll have words that are kind of explaining what's going on in the screen. So there it is basically telling what the people are speaking. But over here, it's basically a title that is, given below the figure, where it tells you what the figure is about, and you can set what that title says. And legends are basically, it's kind of like a helping hand for someone who's not created the figure to actually see what the figure means. So if you have multiple different lines on it, a blue colored line, a red colored line, and so on, you can actually put a legend similar to how it's on maps and geography in school. You can have a legend which shows that, okay, the blue colored line represents data from class A, or orange colored line represents data from class B, and so on. So you can set that. You can even set the color of those lines and stuff. And color bars basically, so if you're using heat maps or you're using something where there is a gradient of colors, like there are different types of colors associated with a particular figure, a color bar is kind of like a legend but from a color scheme. Then we come to the axis. So we all would have heard the X and Y axis and at times the Z axis, right? It shows you whether it's a two-dimensional figure or a three-dimensional figure. So it has the same meaning in Matplotlib as well. So that black bordered outline, which you basically see inside which your chart will be or inside which your plot will be, can be known as the axis. So you generally have two-dimensional plots with the X and Y axis. But at times, the more advanced you get, you will even be creating three-dimensional figures. So the easiest way to remember it is the boundary within which you're putting your plot. And last is the spine. So when you basically draw your axis, you have different demarcations, right? As in, suppose it's in terms of centimeters, so 0 centimeter, 1, 2, 3, 4, and so on. Or age, you'll put the numbers 10, 20, 30, 40. So the line that is connecting all of those, all of those demarcations or all of those marks is known as the spine. Now, when it comes to data visualization, you can generally break up your visualization into 5 particular parts. So first, you need to import the libraries, right? All of these are beautiful functions created by different people. Now, if you want to use that function, how do you actually get your machine to, learn that? How do you get your machine to identify that? So what you do is you basically import the function, as I'm sure you all would have done with pandas and Cbone. So importing the function is synonymous to a person basically sitting, you know, we give him a textbook and we ask him to read from that textbook. That is literally all, programming is. That is literally all machine learning is at the simplest level. So when I'm saying import, NumPy as NP, it's kind of like giving a kid an English textbook or giving a kid a maths textbook and telling that, okay, this is a maths textbook. You can refer to this to solve sums, because in that the solutions will be there, in that the functions will be there. So first thing that you do is importing the library. This is kind of like the first step of helping your computer learn what it is supposed to be doing. Next is you prepare the data. Now, data, it may be in different forms. You could be accessing, a folder of around 1,000 images, JPEG files, PNG files. You could be actually accessing a simple Excel sheet with 10 rows and 2 columns, or you could even be accessing an array or a string of characters. So data can be in different forms. So once you've taught the machine that, okay, this is the place from where you'll be working, from where you'll be learning, you need to give it some data, some sort of example, something to work with. Like, so after importing the libraries, the next thing you'll do is basically preparing the data. Once you prepare the data, now you know what you're working with and the knowledge that you needed to start working with it. Next thing you do is you need a platform to actually put it in. So here I've mentioned preparing the figure. So as I've highlighted earlier, figure is basically your drawing sheet. It's your canvas on which you'll be doing your painting, on which you'll be doing, your sketching, your pencil shading or anything. So preparing the figure, you can kind of understand it as, taking up a tripod or, clearing out a table, putting your drawing sheet on top of that, putting pins on the sides of the drawing sheet so that it doesn't move on when you're sketching. So that is preparing the figure. Now, once you prepare the figure, what you have to start doing is actually plotting it, right? So there's kind of like two steps when it comes to plotting the figure. So what programming languages generally do is, like Matplotlib, for instance, what it does is once you prepare the plot, it is stored in a temporary location of memory, meaning just by drawing it, it is not displayed to the outside world. You have to separately and exquisitely ask it that, okay, I have prepared this, kindly show this. So yeah, so you prepare the plot, it is stored in a temporary location of memory, and then once you show the plot, it is visible to everyone else. So here, for instance, I have a simple program that I can show you all. So firstly, as mentioned earlier, you need to import the necessary libraries. So we are going to work with a module from the Matplotlib library called PyPlot, which is a very simple library. It helps you make basic line charts, bar charts, and scatter plots. And what I've basically done here is import matplotlib.pyplot as PLT. So the words that you can see over here in pink are known as keywords. So they are words stored in programming languages which have a designated meaning. So I cannot have a variable called import. I cannot have a variable called as. The reason is that the machine will actually misunderstand that for something else because it's already understood a particular meaning. It's like if a person is taught a single, saying or taught a single meaning of a particular word for, 10 years, 20 years, 30 years, you cannot change his or her perception about that. It's fixed in their head that, okay, this is the way it is supposed to be. So machines are also kind of like that. They're very stubborn. So they have certain words that you are not supposed to use for variables because they already have a fixed meaning. So what I've basically done here is if every single time I had to write pyplot or matplotlib.plot, the bigger the program gets, the more frustrated you're going to get because that's a lot of typing involved, right? So we've basically assigned a variable called PLT so that every single time I say PLT, the machine knows that, okay, this guy is telling me that he's using pyplot from the Matplotlib library. So that is the first, library that we needed. The second is NumPy. So NumPy is basically a library that is famous for mathematical operations and statistical operations and stuff. So similar to how we assigned this library to the variable PLT, we are going to assign NumPy to the variable NP. Does anyone have any doubts so far?
No, sir.
No.
Y'all don't need to call me sir. I'm probably the same as y'all. I'm just 23 years old. So y'all don't need to call me sir. We'll just keep this informal, and I think that'll be the best way for everyone to learn as well. If any of y'all have doubts, please feel free to just interrupt me in between and just let me know. So yeah, don't hold back. All right, so we've imported the library. So we've basically given that textbook or that coloring book that okay, this is what you'll be learning from, or this is what you'll be drawing. We've basically given that to the computer, right? Now, next thing that we need to do is we need to give him something from that book that he or she will actually be working on, right? So what I've done here is I've used a function. You all know functions, right? So I've used a function called linspace from the NumPy library. So what linspace basically does is you mention the starting point, you mention the ending point, and then you mention how many numbers you want to generate. So what it does is from the starting point up until the ending point. So starting point is 0, ending point is 10. It will take out 100 numbers that are evenly spaced from each other. So as you all can see over here, it'll take 0.0, then 0.101, and all the way up until 10. So it'll start at 0, it'll take at 10, and 100 numbers that are evenly spaced out, it's going to select from that, so that we kind of have like a set of data to work with. Now you can change these numbers to whatever you want. It doesn't have to be 0, 10, and 100. So if you wanted to start with 2, it can start with 2. If you wanted to go on till 20 and you want there to be 2000 instances of data, it's completely up to you. So you can set the starting point, ending point, and all of that for your data. So first position generally represents what number you wanted to start from. Second position represents what number you wanted to end at. And then the third position will tell you how many values you wanted to pick out from that, which are evenly spaced out. So this is basically what linspace did. So since we didn't have any data set or any collection of data to work with, I thought might as well generate a new one. And as you can see, I've used the type of X command over here. Does anyone know what that does? Okay, so you have different types of data, right? You have different data types. You have integer, float, string, char, and all of these types of data types, right? You all would have done data types by now.
Yes.
All right. So at times what will happen is, for instance, if I give this program just out of the blue, if I give this program to any one of you all to run, I have full confidence that you all will be able to run it. But what if you all want to understand and see? Because if I didn't mention this line, right, there is no way of telling what what type of data the variable X stores, right? So the function type is basically what we call as an inbuilt function, meaning when you install Python or any of these programming platforms, the the function type basically identifies and tells you. So if I pass the variable X inside the function as a parameter, it basically tells you what is the data type. So for instance, if X contains the value 10, over here, if I put X, then it would show me over here class int. So it basically tells you what the data type is. So it's a very useful function and a very simple one that will help you understand the program quicker and know what kind of data you're dealing with. So what I can actually do is I can share this notebook with you all, so that if you all want, you all can execute it side by side with me, and I think that will be a better way to go. Okay, can't seem to Okay, so I'm attaching the file into the chat. Let me know when you all can see it. So if you all want, you all can open it up and then we can continue with the workshop. So far, does anyone have any other queries?
No.
All right. If you all have, you all can speak up. Trust me, programming was not something I got in the first instance. In fact, like I struggled for a whole year before I even started considering programming as a proper subject. Till then, I was just arguing that, okay, I don't need to be doing this. It's not being used anywhere. But like, yeah. Okay, I think it's in the chat. Is everyone able to access it? All right, awesome. So, okay. So, yeah, as I mentioned, type basically helps you understand. It's one of those very useful functions that helps you understand your data better. And it'll basically tell you what your data is, like what type it is, what type of data it holds and stuff. So, yeah, so I've basically created what is an array over here. So array is basically a collection of like-typed variables which are referenced by a common name. So what that basically means is if I have numbers, right? I have 1, 2, 3, 4, 5, 6, and so on until 10 or 20 or 30. I can call those numbers rather than calling each and every number by assigning a separate variable. Like I'll put the value 1, unable to see it, the collab link. Okay. Samapika, you're not able to access it from the chat?
No, actually, I can't see the link here. I don't know if there's a technical issue or something, but I cannot see it.
Okay. Is there any email ID that I can forward this to?
Yeah, there is a Google group for this intermediate class. I think it will be better if you can share it via Google group.
Probably you can continue with this presentation and later on they will practice because we have only 1 hour time, so we can't. If they are practicing live, it is maybe a little bit difficult. So what I prefer is so you can present this one, and after
All
that we
right.
can share this one. Yeah.
All right, sure. So I'll be sure to share this with you, and I've made sure that I've mentioned all of the details in this itself. And yeah, I'll add that to the Google link after the session. So yeah, so type is basically it helps you with the data. So when you have n number of variables that are of the same type, right? So if I've stored the value 1 in A, if I've stored the value 2 in B, 3 in C, if I have to access 10, 20, 30 different variables, 30 different data, each and every time if you have to access it with a separate variable, it can get very tiresome, right? The bigger the program is, the more tiresome it will get. So you have a type of data type called an ND array, which means an n-dimensional array, which basically what it does is rather than you storing each of these 100 values in a separate variable, it basically creates one variable, which in our case we've stored it in X, and in that one variable you can access all of these values. So each and every of these 100 values is stored in that one variable, and that data type of that variable is an ND array, an NumPy ND array. So if you want to access only the first position, you use something called indexing, which I think you all would have done by now. So indexing basically, so on the 0th position, you'll have the value 0. First position, you'll have the value this. Second position, this. Third position, this, and so on. So it goes from position 0 to n minus 1. So n meaning how many ever values you have. So if you have 100 values, the value of n is 100. So your positioning and your indexing goes from 0 to n minus 1. So 0 to 99 is the position. So if you want to access the last one, it will be 99. So it basically, what we've basically done is we've created 100 values between the number 0 and 10 that are evenly spaced out, and we've stored that into the variable x, which is an array. Now, I've basically use the print function to basically display the values so that we know what we're working with. And next, what I've done is I've used, so as I mentioned, we imported the libraries over here. We've prepared the data that we'll be working with. Next thing is we need to prepare that drawing sheet, right? We need to prepare the canvas. So I've used a function called plt.figure. So as you all saw at the top, plt is basically the variable we've used for Matplotlib and the pyplot function of that particular library. So plt.figure basically instructs the computer that, okay, hey, I need you to use this particular library to create a blank figure on which I can draw. So this big white space that you see is what your figure is. In this diagram, the entire white space is your figure. Now, once we've created the figure, the next thing that we do is we need to put the drawing onto that, right? So next thing we're going to do is we're going to again use the same library using PLT. PLT dot plot is, so plot is basically the function that you use when you want to draw a line chart. So this straight blue line that you see is a line chart. So we are basically telling it that, okay, use the library pyplot using the variable plt and use the plot function or the plot module from that library to basically display the values, right? Display the chart. Now, x and x, these are basically parameters that I've passed, telling it that, okay, what values do I want it to pass? So the first position is for the x-axis, which is the horizontal line. Second position is for the y-axis, which is the vertical line. Now over here, I've passed the same value twice. If you have two different types of data, you can pass it, you can put x here and y over here, or whatever variable you want to pass, you can pass. So since my x and since the x and y axis both have the same variables, it is basically drawing a straight line at around 45 degrees. So showing that, okay, when the value of x is 0, y is also 0. Value of x is 2, y is also 2. 4 and 4, 6 and 6, 8 and 8, 10 and 10, and so on. So this is basically, so this line basically contains all of these 100 values that were there inside this particular array. Any queries?
No.
All right. And as I mentioned, so once you draw it, that is not enough. So if I don't put plot.show, you all will not be able to see any of this. So you have to explicitly tell the machine that plt.show is basically the command that you use to display the plot to the people. So the machine already knows what's been drawn, but for us to be able to see and for it to tell us that, okay, show me what you've drawn or show me what homework you've done, you're basically using the plt.show. So the machine is basically like a kid. Like you ask it to solve a sum in a tuition, it will solve the sum. But then you have to see whether it's correct or not. You have to see whether he's actually done it or not, and so on. So this was like a basic line chart that you can do. Now, what we can do is I can show you another example. So sine and cosine functions are some mathematical functions that I'm sure a lot of us would have been frustrated with in school. So sine and cosine functions are also something that you can actually plot over here. So as seen above, I've used the same function, np.linespace, and libraries I've already imported. So once you import the libraries in a particular program, you don't need to do it again and again. It's still stored as long as the program is running. So what I've basically done is I've specified the starting range and ending range. So np.pi is basically, so minus np.pi, meaning the negative value of the value of pi. So we would have used, right, the simple pi, 3.14159.265 and so on. So the values are basically running from minus 3.14 up until plus 3.14, and I'm going to select 256 values within this particular range. So an endpoint true basically says that, okay, I want the starting point, meaning minus 3.14 and plus 3.14. I want the starting point and endpoint both to be included in this set of values. So we've basically used the same function again, and now we've just created a different array, which will give us 256 values between minus 3.14 and plus 3.14. And so for, as you can see over here, the graph is running from around minus 3.14 to plus 3.14. Now what we're going to do is we are going to create a variable called func cos, which is basically a variable we've chosen for the cosine function or the cos function. And we're going to use the function cos of x, which is a part of the NumPy library. So np dot cos of x. So the library name dot function name of, and then x is the parameter, will basically create the cosine function or the output of the cosine function for the data that you have specified inside that, and it will store it into the variable of func cos. So for sine also we've done the same thing. So func sine is the variable we've used for this case. Using the library dot function and then the parameter inside, we are creating the sine function of the values of x. Now, once we've prepared the data, we'll go on to preparing the figure and the plot. So you can combine this into one. So plot dot figure. So first it will basically draw this white space. Then plt dot plot x comma func of cos. So as you can see, x, the values is going to be on the x-axis. Func cos is the values that it's going to plot on the vertical axis or your y-axis. So so we've done that for the cosine function, and at the same time we've done that for the sine function. So as I mentioned earlier, you are not limited to just one particular chart on each canvas, on each figure. So over here you can see that there are two overlapping ones over here. We have the blue one, which is the cosine function, and the orange one, which is the sine function, right? Now, for me, or anyone from a mathematics background, we may know that, okay, blue is a cosine function, this is a sine function and stuff. But at times, you may not always be able to tell which is which. You need some sort of distinguishing factor. You need some sort of help to tell you that, okay, which plot actually stands for what, which is where your legends and your labels basically come into play, which I'll be coming to in a bit. So similar to earlier where we had a simple line chart, you don't necessarily have to always give an array as the data set, right? You don't have to just pass a variable. You can even actually pass the values itself. So for instance, we have an array of the numbers 1, 2, and 3. We have another array of the numbers 4, 5, and 1. And I've basically passed this. So 1, 2, and 3 will be on the x-axis, and 4, 5, and 1 will be on the y-axis. So these are basically coordinates. So the first coordinate will be 1. So the value of x is 1, value of y is 4. So when x's value is 1 and y's value of 4, we'll plot this point. Next will be when x's value is 2, y's value is 5. So 2 and 5 is the second point. And then the third one is when x's value is 3, y's value is 1. We'll have this point. So, and again, plot dot show to make sure that you can actually see the figure. Now, as I mentioned earlier, you may have times where you have, multiple plots on the same area. Now, how do you actually identify, or how do you actually make it easier for the person viewing to understand the data? So here you have something called your labels or your titles. So for instance, so we've assigned the variable. So we have one array, which is x, having the values 2, 7, and 14. Another array is the array y, where we have 5, 8, and 4. And what we're going to do is we're actually going to tweak the figure a bit so that we can actually see. So plot dot figure, as I said, will make this white canvas or the white drawing sheet on which you'll be typing. Next, you'll have your plt dot plot. So you'll mention the x-axis, which is horizontal line, y-axis, which is your vertical line, and then you're basically going to give a label. So a label is just going to tell the viewers what this blue line represents. So for instance, I have written label is equal to data. If I wanted to type something else over here, if I put series, so it basically changes the name of what that particular line represents. So you could put anything over here. So if you're making if you have data regarding crime statistics of a particular police precinct, or if you have data regarding the weight of a particular class of students, you can just put that over here and you can name the line whatever you want. So on the basic level, it is literally just naming the line what you want. So once you've named this particular line, if someone sees the chart, they should know what the chart is about, right? So we are basically going to use the plot.title command to give a title on top of our chart. So we've named it basic line chart. And as mentioned, you can write anything you want in between, inside this. So basic line chart is basically the title or the name of this figure that we'll be given. And you're not limited to just this line or the chart. You can even label this as the x-axis and the y-axis. If this was age, x was age, y is weight, I could write age over here, weight over here. So it's absolutely up to you. Now we know that, okay, this is series. Now how do we display it to the user that this particular line represents series or represents data? So you'll use plot.legend. Now, plot.legend basically creates a guide for anyone who is, viewing your chart, and it explains to them that, okay, this is what the data is actually representing. So legend is not that useful when you have only one particular line, because you'll know what it's about. But then if you have multiple lines, it'll be useful to see that, okay, blue line represents A, black line represents B, the magenta line represents C, and so on. So now style. So you are not limited to just one look when it comes to Matplot. You can customize what your chart wants to look like. So for instance, we saw over here that, okay, it's a pretty bland looking chart. You can actually make the chart look more attractive, and you can change the way it looks by using a module of the Matplotlib library called a style. So style, basically, it'll allow you to choose and pick between different types of looks that you wanted to assign for your chart. So can you all still see my screen?
Yes, we can.
Okay. I'll just zoom in a bit so it'll be easier. So this is just some of the different types of, you all can see the Chrome browser, right?
No, your collab.
Okay, it's still showing that screen. Okay, just hold on.
Srika, stop the screen sharing and again share that.
Yeah. Is it visible now?
Yes.
Yes.
Okay. So there I use something called ggplot. So you're not limited to just one type of chart. You can customize the themes, customize the colors. This is one of the ways where, Matplotlib is kind of becoming similar to Cbone. Like, it has predetermined themes. So every single time you don't have to tell that, okay, line 1 has to be B, line 2 has, line 1 has to be red, line 2 has to be black, line 3 has to be cyan, or any of those things. You can actually choose between default themes. So by default, if I don't mention anything, this first row is basically the type of colors that you're going to see. So if it's a simple scatter plot, you'll see this. If it's an image, you'll see this. If it's a bar chart, you'll see this, and so on. Now, there are many different looks and feels that you all can, experiment with, and you can choose and see which one you like. So you have classic, you have Solrise Light 2, and all of these are actually charts that have been created by people like you and me. So you can actually go crazy, and if you like a particular theme, from anything like a movie, a TV show, anything, you can actually pick up that theme and make something close to that. It would take a lot more programming, but it is possible. So you have classic test, BMS. If you like a dark theme or a dark background, you have this, and so on. So the one we are using is called ggplot. So as I mentioned, so you can have a scatter plot like this, you can have an image, a bar chart, and so on. So I'll get back to the program. Okay, so program's visible again, right?
Right.
Awesome. So as I mentioned, so you have different types of styles. So all you have to do to select a different style is over here, instead of ggplot, I'll type dark theme, or I'll type BMH. And then again, you run that particular type of code, and it will customize your entire look according to the theme and according to the default settings that is there for that particular style. it's kind of like, so on your phones, you'll have your, your light theme and your dark theme. Phones like OnePlus might have a few more options. So it's as simple as that. So you can just change the look and feel without having to worry about changing each and every line or each and every color. You can still choose to do that, but you don't have to. So now that we've imported the library and we've, selected what type of theme or what type of style we want, the next step, as always, is preparing the data so that you can work on it. So here, what I've done is I want two charts on the same figure. I want two charts on the same canvas. So I've taken the values 25, 26, and 30 for the variable x1. So we have an array over here for the variable x1. For y1, we have 10, 15, and 7. For x2, we have 36, 29, 31. And for y2, we have 16, 21. So these are basically coordinates of two different lines. So x1, y1 will give you line 1. x2, y2 will give you line 2. Now, as I mentioned, if you have two different lines and you want to tell the person that, okay, the orange line represents something and then the blue line represents something. So how do you actually do that? So that is where label comes into play. So label is one of the parameters that you will pass in your plot function. So after you mention the x coordinates and the y coordinates, you'll basically put label is equal to, and then whatever you want to name that line. So this can be age, weight, height, anything that you want. Similarly, if you want that, okay, line 2 needs to be called data 2, you'll put label is equal to, and then the name of that particular line. And once you do that, it's automatically going to identify that, okay, this is data 1, this is data 2, or vice versa, depending on how you set it. Now we want to, so this is basically a demo of what the style part of Matplotlib is. So I named the chart style demo. So I did that using the title function for PLT. And as previously done, I just used Y label and X label to name the vertical axis as the Y axis and horizontal one as the X axis. Now, you would notice that, okay, there are these lines in the background of the chart, right? Those are known as grid lines. It's the same meaning as what you have, in your phone camera. If you open the phone camera, you'll have, the 2-line by 2-line grid. It's the same thing. It basically gives you a reference so that you don't have to physically, try and track with your either, okay, 26 is roughly over here, or 8 is over here, or 10 is over here. So it just makes it easier for you to view where the points are and where they'll actually be plotted. So it's easier for you to see that. So I've basically done plt.grid, where grid is the function, and I've passed the value true over here. So true basically means that I want the grid lines to be visible. If I set that to false, the grid lines will disappear and you'll only have the gray background. Now, apart from choosing whether the grid lines are seen or not, and apart from the theme that's already there, you can actually even choose what color you want the grid lines to be. For instance, if I want them to be pink, which is the color magenta, I can just pass color is equal to M, and then I can run that cell again, and you can change this color. So if I want them to be light blue or cyan, I can pass C, and and it basically changes the color. So you have set codes and you have set characters that are associated. So C means light blue, it means cyan. So you'll have G for green, you'll have, I think, Y for yellow, K is for black, W, I think, is for white. So you all can actually try and experiment it. And as I mentioned, create your own themes with this and make the chart look, appealing to yourself. And yeah, so now that we know that, okay, line A means data 1, line B means data 2, we need the person seeing the chart to be also able to see that, right? So again, I've used the legend function over here. And since we have two different charts, it's actually useful over here to tell us that, okay, the orange line means data 1 and blue line means data 2. And it's not limited to just 2. You can have 3, 4, 5, as many lines as you want on the chart. And if you put a legend, it will be easier for you to see at a glance, and you won't have to go through the code to understand that, oh, wait, yeah, I had kept data 1 for the blue line and data 2 for the orange line. So it basically helps you customize that to your liking. So next is, as I mentioned, Matplotlib is something that is extremely customizable, right? So we saw how we could actually change the theme or the style of the entire plot. We saw how we could plot more than one lines onto the same canvas, onto the same figure. We saw how to change the color of the grid line, how to change the color of the lines, how we can actually change, whether we put a legend or not, whether we label the diagram or not, the axis or not. Now you can even go further beyond that. So over here we have, very sharp turns over here. So we can see that, okay, this is point 1, this is point 2, and this is point 3. Now, what if you have lines that are almost like it's a small zigzag line that's almost parallel to a horizontal line or almost parallel to a vertical line? In that case, and if you're not able to zoom in, you may not be able to see where each and every point is, right? Now, that could be a very big problem if you're trying to identify very crucial things from the data. So for that, you have something called markers. A marker is kind of like on a treasure map, the way you have an X marking the spot where the treasure is. A marker is kind of like that. It will basically show you where each and every point is. Now, that could be an X mark, it could be a star mark, it could be a comma, it could be a left arrow, a right arrow, a triangle, circle, whatever you want. So markers basically help you literally mark where each and every point is on the line, so it will be easier for you to follow. Next, you have something called line style. Now, for instance, I don't want, like here I have a solid line, right? Now I can choose whether I want a solid line. I want it to be a line of, multiple dots. If I want it to be dots and dashed. So I can choose how I want my line to look. And there are specific codes again that, specific terms that, okay, if you just put inside a bracket, if you put dot or dash and dash or dash and dot, it'll help you choose and actually see how your line looks. And then the third is the line width. So if the line is extremely thin and I want it to be thicker, I can actually specify how thick I want it to be. So here I have another example of that. So we've imported the libraries already. So what we're going to do is prepare the data. So as mentioned earlier, I have X and Y points for line 1, X and Y points for line 2. Now we've prepared the figure, which is drawn the white space. Next, what we're going to do is prepare the first line's plot. So I've parsed the X coordinates, the Y coordinates. I've put G over here for the color, which means that I want the line to be green in color. And I'm going to label it series 1. So as you can see over here, the green line is series 1. Now, as I mentioned, marker, line style, and line width. So over here, I wanted the markers to be dots. So point 1 will be represented by a dot, point 2 by another, point 3 by another dot. Now, if I want this to be, suppose, a star, for instance, I just put a star over there. And when I run it, you can see that, okay, it has actually shifted the dot into a star. So if you can come up with an equation, or if you can come up with a data like that, you can actually draw, you can make your data represent a constellation or a nakshatram or something from the sky as well. So you can make your visualizations look that creative. So a marker will basically tell you, and it will mark where each and every point is on your, on your plot and on your data sheet. Next, you have your line style. So over here, I've mentioned a simple dash. So a dash represents your normal straight line. Now, if I wanted to change that, and if I wanted to make it, if I put dash and dot, I think that should basically change it to a dashed and dotted line. So you all may not be able to see this because I can't zoom in. But over here, you can basically see that, okay, rather than a fixed solid line, it's made it into dashes and dots. So yeah, so you have that. And then the last one is your line width. So a line width is basically how thick your line is. So if 1 is generally the default value, so if I've passed 1, it will be a really thin line. But at the same time, for the second one, you can see that I've passed 5.5, and it is basically like, this is with a pencil and this is with a marker. So you can see the difference in the two. So even for this, I can change the way the line is, the style it has, the way the marker is and stuff. So it's completely up to you. And this is one of the beauties of Matplotlib, that it lets you customize it as much as you want. And yeah, as earlier, we've given the title, which is custom line chart. We have your x-axis and your y-axis. Any queries so far?
No.
Okay. So if anyone wants to know, what all types of markers are available or line styles are available, I can just share the links. Or even if you just, Google that, okay, types of markers in Python or types of line styles in Python. This is another perk of this language, that everything is open source. So all of the documentation and all the notes of this are available from the creators itself. You don't have to pay anything for that. So you can just Google it and you can find that, okay, if I replace star with, uh, you know, uh, greater than sign, then what will it do? If I replace it with a less than sign, what will it do? If I put a dot instead, what will it do? So you can basically pick and choose how you want it to be, and everything is just available online. So you don't even have to search too far for it. So we've explored line charts a bit. Next, we can come to bar charts. So bar charts are generally used when you want to show a comparison between two things. So if you want to show, the sales of car A versus the sales of car B, or you want to show, how many COVID cases were there in month one versus month two, or how many exams were conducted in last year and this year. Bar charts are very useful when you want to show comparisons between two or more values, or if you want to show how something has changed. So line charts, on the other hand, is generally used for something called a time series. So it basically tells you how a particular variable or how something has changed over time. So if you want to see a trend, or if you want to see how something's moved over time, a line chart is generally better for that. So bar charts are generally used for your comparisons. So every single thing about the whole process is the same. You still import the libraries, you still prepare the data. Only thing that changes is literally this function. So where we were using the word plot, PLOT, for your for your line chart, you simply just have to put the word bar. You put bar, and the machine understands that, okay, the data that he is going to give me, or the data that she's going to give me, I am going to use that to create a bar chart. So for 5, 8, and 10, you can see that for 5, the intensity was 12. For 8, the intensity was 16. And for 10, the intensity was 6. So that is as simple as it is to create a bar chart. So unlike Excel, you don't have to manually select the data, then go into one option, then select that, then over there you select the chart and stuff. At times that may be easier, but at the same time here, you have these commands and you can use that to create a bar chart as well. So here I've been passing the data as arrays. You can even just pass an Excel sheet or a PDF or a Word file, or any different type of file where you want to access the data from. So that is the basics of how do we pass a bar chart. Now, now what do you do if you have two different, there's something called a stacked bar chart, where you're basically showing a comparison, suppose between the values of the year 2019 versus the values of the year 2020 of how many dogs and cats were adopted that particular month of a year. So for instance, if I had to check that, okay, in December 2019, how many dogs were adopted from animal shelters, versus in 2020, how many dogs were adopted from animal shelters. Now, in these cases, if I show two bar charts next to each other, like if I show one over here, then one over here, then one over here, then one over here, your graph can look very cramped up, right? It's not visually nice to see. It can even seem frustrating at times. So instead, what you can do is you can use something called a stacked bar chart. So a stacked bar chart, basically, for the same values of X that is there, which is 5, 8, and 10, it will put the different values of Y one on top of the other. So you can easily see that, okay, in the first case, series 1 was better than series 2, because the orange is basically going down right from the bottom up until here. In the second case also, orange was better than blue. And in the third case, since it's only blue, meaning blue was better than orange. So as earlier, I've basically prepared the data, I've assigned the values. Next, what I've done is I've basically prepared the plot. So first one is series 1, which is in orange. Second one is series 2, which is in blue. And then I've plotted the same thing. Now over here, what will happen if I pass the same values for X and Y? Anyone wants to take a guess? what do you all think will happen? So the value of x is the same, but what will happen if I pass the same values for x and y? Any ideas? Okay. So as you can see here, since they are stacked, like they are literally one behind the other, you will not be able to see the other color. So whatever the latest one is, right? If you have 1, 2, and 3 values, whatever the third value is, since that's the frontmost, like that's the closest to your screen, you will only be able to see that color. So here it basically means that all of the values were, neck and neck, like all of the values were the same. So it's one behind the other. It's kind of like taking, if I have two towers that are around 20 stories each and I line them one behind the other and I'm just looking straight dead on onto the towers, I will not be able to see the one behind it, right? I'll have to see it from a slightly tilted angle or something. So it's the same thing over here. So if you have the same values, whatever is the frontmost one or whatever is the last value is what you'll basically be seeing. So since series 2 was the later one, you will see that the values for all of them is just showing blue because that is the only one that they're seeing. Now, as mentioned earlier, you can customize, similar to how you customized your lines, you can even customize your bar charts. So you can set different colors for it. You can, yeah, like, so here, for instance, you can basically change the colors to do whatever you want. And you can change the grid color also to black or green or whatever color you want. So this is again another example of how, Matplotlib is extremely customizable. So you can make it look like whatever you want. So in presentations, if you have a black and orange theme, you can actually change the whole thing to make it match that theme, as long as you know the right, alphabets or like the right characters associated with a particular color. Next is coming to scatter plots. So scatter plots is a good way to actually see an overview or a distribution of how your data is scattered, like how far away the points are. And it is something that you use to see whether variables are affecting each other or not. Like, is there any trend? For instance, if I plotted the scatter plot and I saw that, there's a constantly increasing line like this, it would tell me that, okay, as the values of X increase, Y is consistently increasing. But since it's scattered in this way, there's no particular relation as such that I may be able to pick up directly. So again, for scatter plots also, the whole way of doing it is the same. Import the libraries, prepare your data, prepare the plot. And again, the only different factor is instead of using plot for a line chart, or instead of using bar for a bar chart, you just use the word scatter and it tells the machine to, okay, pick out a scatter plot. Now, again, so here also, if you want to change the colors, you can just by simply mentioning color is equal to, and then you can mention what color you want it to be. And then if you just run it again, you'll get this. So B is for blue and K is for black. Now, over here, you can see that, okay, no handles with labels found to put in legend. So what this basically means is we have asked the machine to put a legend and show what data means what. Now, over here, I have not mentioned that, okay, the first scatter plot is the one in blue or the second scatter plot is the one in black, right? I have not put label is equal to series 1 or label is equal to series 2, which is the reason that the compiler, which is basically the entity that's executing the program, it's telling me that, okay, you want me to make a legend, like you want me to make a guide, but you have not guided me or you have not told me what each data, or what each line is supposed to represent. So, which is the reason why we did not get this message when we ran the first two lines of code, because there we had specified what it meant. Is everyone following? Any doubts? All right. So next is basically a histogram. So a histogram is similar to a bar chart, but they are generally closer together rather than being spaced out. And you can actually also use this to compare, the same set of values and see how it is changing over different intervals. So for instance, frequency distributions, you generally use a bar chart rather than, frequency distributions, you'll generally use a histogram to see how often something is happening or how many times a particular value is coming in a set interval. So here, for instance, I have ages. So I have a set of, you know, this many values. So we have students or people from the age of 22, 55, 62, 15, 21, 22, and so on, up until 130, I think is the maximum, right? So next, you have your set of values. Now, how do you actually group them? Like you would have used group by functions before, right? So how would we actually group them and put them into type A, type B, or class A, class B, and so on? So we are going to specify something called bins, which is your intervals. So it basically tells that, okay, I want you to take these ages and I want you to put them into whether they are between 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on. So we've specified the values over here and we've specified the intervals or the bins within which we want those values to fall. Now we'll prepare the plot, and just like earlier, it's very simple to create a histogram as well. Instead of plot, instead of bar, instead of scatter, all you have to do is you just have to mention the function hist, which indicates, it tells the machine that, okay, create a histogram. You will pass the x variable, which you want to be on the x-axis. You will pass the y variable, which you want to be on the y-axis. And then over here, you can see that I've passed hist type step, which basically tells them that, okay, I don't want to see, blocked out figures. I just want to see the outline of the thing. So instead over here, if I pass bar and then I run the same code, you can see that it's actually colored in the entire thing and it's showing me what kind of looks like a very funny building. So it basically shows me how all the data varies, and you can see that the maximum age group is falling within the 40 to 50 range, and so on. So yeah, so you can customize it, and if you feel that this looks too bold, or if you want just the outline, you can just mention step in your his type, and it will again give you only the outline, which is a bit more easier on the eye at times. Now over here, I've specified color is equal to M, which is basically magenta. And just like in all the other ones, the codes are the same. You can put C if you want cyan. You can put, so you can see the light blue color. You can put K if you want black, and you can change it. And R width will basically tell you how wide you want the lines to be. Sorry, how wide you want each of these bars to be. And yeah, you can customize it depending on what type of data. If there's very little data and you feel your graph is looking very empty, you can actually, shift this to a bar chart, and you can change the width to make it more accommodating and make the whole graph look full. So now, when it comes to your bar charts, right? So far we always saw that, okay, on the X and Y axis, the labels were always numbers. We saw that, okay, down it was, age. On the Y axis, it was marks in a subject or whatever. We always saw that it was numbers. You're not only limited to numbers. So you would have heard of the data type called string. You can even pass strings for your X and Y axis as well. So, so for instance, I've taken AA, BB, CC, and so on. And I've again made a simple bar chart. So you can see that, okay, on the X axis, you can actually have your strings rather than integers. You're not limited to just that. And suppose I don't want, just the strings to be there. If I wanted to actually show the number of classes that are there, so I'll use the range and length function. Okay, so length and range are also inbuilt functions in Python. What len of x1 basically does is it calculates the length of a particular thing. So for instance, if I put len of x1, it is going to physically count that, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 values. So len of x1 will basically return an integer value 10. And range basically means that, okay, I needed to run from here up until 1 less than y1. So if I execute this, sorry, yeah. Okay, so here you can basically see that rather than it printing the names of each and every type, it is actually running from the beginning up until how many values are there. So roughly from 0 to 10. So it is showing that, okay, around 0, it is, 173 values. On 1, it is 135. On 2, it is 141. 3, it is 148, and so on. And indexing is same over here as well. It starts counting from 0 and will go on counting them 1 lesser than the value you have said. So if you said 100, it will count from 0 up until 99. So that is how your range function basically works, that you specify a range rather than you mentioning 1, 2, 3 up until n numbers. You specify range so it knows where to start and where to end. Now we use strings over there. You can also use date and time. So date time is another library with Python that you can use whenever you want to access the date of a particular, you want to access the month, year, day, or anything from Python itself. So we've assigned datetime.datetime, which is basically library dot function, same format as earlier. And I've mentioned the year, I've mentioned the month, and I've mentioned the day. So it follows the YYYYMMDD format, which is year. So 4 spaces for year, 1 or 2 spaces for month, and then 2 spaces for day. So I've basically passed value 1, value 2, value 3. So 21st, 22nd, and 23rd of January 2020 is the 3 dates I've passed. And y1 is basically going to be the value. So this can be, suppose, the number of, pizzas ordered for a particular party that took place on 21st, 22nd, and 23rd. So on 21st, they ordered 6 pizzas. On 22nd, they ordered 10. And on 23rd, they ordered 7. So over here, I've basically used the plot.bar function to plot a bar chart. And you can see that, okay, on 21st of January, it is plotting that 6 pizzas were there. 22nd, it's plotting 10. And 23rd, it's plotting 7. So yeah, again, it's just what you do with that one word, whether it's plot, whether it's bar, scatter, or hist. Now we'll just step it up one level. So data frames is something you all would have come across, yes?
Yeah.
Yes.
All right. Can someone tell me what a data frame is then?
It's a collection of data. I mean, for example, if we want to store data about a student, number of students in a class, so say their roll number or their DOB or their section, their branch, so we can create a data frame based on that. So similar like that on different topics and things.
Exactly. So a data type is basically a tabular form of data. So generally when we are working with CSV files or Excel files, we use a data frame because what it does is whatever columns and rows is there in the Excel sheet, as it is, the machine itself converts it and transferred it into a data frame. So one of the key reasons why we actually use a data frame is so that every single time, if I'm directly working with the Excel sheet, right? Firstly, it is going to, whatever changes that I make in the program, it is going to be editing the Excel sheet itself. And you may or may not actually want that. If you have sensitive data and whatever changes you're making are changes that's happening in the Excel sheet directly, there's no way of going back, right? It's kind of like if you write in a notebook with a pen, you can't really erase that. But at the same time, if you write with a pencil, you can erase it and then you can try it again. So a data frame versus an Excel sheet is kind of like a pencil versus a pen. So a data frame also is a temporary location of memory that is stored when your program is running. So whatever changes you make in your data frame is only being made in the data frame. It is not affecting the Excel sheet until you store it separately as an Excel sheet. So I saw that Salman has mentioned dictionary. So it's close. Dictionary has something called key value pairs. So even in that, you may have, you can store an Excel sheet type of values, but generally we don't, because what happens is, so for instance, okay, I have created a data frame here, right? So first column is name, second column is surname, then you have female, as in whether their gender is male or female. You have age, pre-hold numbers, and post-hold numbers, right? So in a dictionary, what happens is you're not directly storing values in a column. So if I have the column name, the column name is not just going to store Charles. It's going to have something called a key and a value pair. So what that means is, rather than directly addressing or directly accessing a particular type of data, you can either choose to access the value of that data, or you can choose to access kind of like a key to that. So the name dictionary, for instance, it comes from, if you're looking up for a meaning of a particular word, right? So if I'm searching in a dictionary, there are two ways that I can actually search for something, right? If I know the word, but I don't know the meaning of the word, I can go into a dictionary. I can open the page D, pages associated with the words starting with D. Then I can start looking for words starting with DI, then DC, then DICT, then DICTI, and so on. So I can start looking either from the word, or what we can call as the key, if I know the word, but I don't know the meaning. Or if I know the meaning, then I can start looking that, okay, give me the word that actually means water falling from the sky. For instance, I don't know the word rain, but I know that, okay, there is a word that describes what happens when water starts pouring from the sky. So I can start either searching for the meaning, which we can call as the value pairs, or I can start searching for the word itself if I don't know the meaning, which is called the key. So that's why it's called key and value pairs. And it's similar to how a dictionary works, where you can, search for one or the other. So that is what the name is. But I'm glad that, dictionary is another term you're familiar with, because that is also something which we use quite a bit in programming. So yeah. So is anyone over here a fan of Brooklyn Nine-Nine, the TV show? No? All right. So I actually recommended this, straying a bit from the topic, but I genuinely recommend it. It's a good show, lighthearted. So what I've basically done is I've taken the names of some of the characters from the TV show. So you have Charles Boyle, Terry Jeffords, Rosa Diaz, Jake Peralta, and Amy Santiago. So, and what I've taken is I've created. So we needed to prepare and create the data. So I created a data frame. So I created a tabular form of data where the columns are name, surname, female, age, their arrest numbers before their captain arrived, and arrest numbers after their captain arrived, to see what sort of effect he had. Now, for name and surname, you'll see that, okay, it's simply their surname, it's simply their name and their surname. For female, does anyone know why I have mentioned 00101?
Zero
True and false.
Yes, very close, yes. Sorry, I lost your voice in between.
0 is not female and 1 is female.
Exactly. So when you're working with larger amounts of data, right, like this is a very small table. I have data sets that, okay, you'll have an Excel sheet which is around 6 GB big, meaning it's so big that, like, my laptop has around 16 GB of RAM and it crashes every time I even try to open the Excel sheet. Like, I just get a message that the file is too big, right? So what happens is you need to save memory in different ways so that it's easier to work on the files. And at the same time, if every single time I had to mention female or male or whatever, that is taking up a lot more memory, right? Here it is just one number, but then each word is actually either 6 letters or 4 letters and so on. So I basically put down a code that, okay, if I say 0, then it is male. If I put 1, it is female. So as one of you mentioned, true or false, yes, it is actually a true or false type of situation where, okay, if I'm asking whether it is the person is a male or a female and they return 0, it means that yes, it's true that the person is a male. If I'm asking if it's a female and I mention 1, then it means it's true that it's a female, but false if it's a male. So I've simply just put the code 00101 so that you don't have to every single time type whether it's a male or a female. So you can even name this as gender. So I've basically created 1, 2, 3, 4, 5, 6 columns over here with the names, surnames, gender, age, and their RS numbers for that particular precinct. Now, data, and then you use this is basically creating a table where all of these values are stored. Next, what I'm going to do is the library pandas, which I'm sure you all will be familiar with. It's one of the most popular libraries in Python, arguably the most popular library. So I'm just going to take a variable df and I'll use pd.dataframe. So pandas.dataframe is the command that you use to basically create a data frame. So I'll give the data, which is specifying what data I wanted to take, where the column names are basically name, surname, female, age, pre-hold numbers, and post-hold numbers. When you are creating this, be very careful that the column names that you're mentioning over here and the column names you're mentioning over here are the same. So as Salman mentioned, like in a dictionary, if you're accessing column names from here, it has to be the same over here, because if I mention, either if I put names, if I just put an S in the end, it is going to return an error because it doesn't see anything called names over here. It only sees name. So when you're accessing keys or you're accessing value pairs, make sure that you're checking for case sensitivity, whether it is capital or not. Make sure you're checking for spelling mistakes, because for us, it may be easy for us to understand that, okay, name and names, it's probably, they just typed S by accident. It's okay. We can take it and go. But for a machine, that may not always be the case. So just make sure that, okay, when you're checking for that key value pairs, you have to always specify exactly what the name of the column is. So whatever column names you've taken here, as it is, you will copy paste it over here because it has to be the same column names. So then this command, what it'll do is it'll basically create the column names. So all 6 of these, as you can see over here. And then for each of the data that's over here, which is 5 data points each, is going to put all of that data under the respective column names as picked up from this dictionary. So good, you identified that, Salman. So yeah, so as you can see that we have a data frame created over here, and what you can, yes sir.
Sorry for interrupting in between. I think we need 15 more minutes, right? How much time do we need?
Yeah, I'm almost done. It's just 3 more boxes.
Yeah, okay, yeah. Actually, I have a class around 10 o'clock. So I'm leaving now. I have to go to office now.
Okay.
So probably, guys, Srikar will end the session, and yeah, we will see you later on. Yeah, you can carry on, sir.
All right, sir. Yeah. Okay, so as you all can see, we have the data frame ready over here. 0, 1, 2, 3, 4 are basically the indexes. So it's telling you that, okay, if you want to access the name Charles, you just have to mention name of 0. If you want to mention, suppose Diaz, you have to mention surname of 2. So indexes are an easy way for you to access that data. Now, scatter plot. So so far we had like just random data that we had taken. Now for a scatter plot, if I actually want to see that, okay, depending on their age, is there any relation between the age and the number of arrests that those particular policemen had taken? So previous scores is basically what their scores were before the new captain arrived. Post scores is basically your updated scores is basically how their performance was affected after the new captain arrived. So on the x-axis, I had taken df.age. So if you want to basically access a particular column, like you all would have done this in grouping and slicing and stuff, want to access a particular column, you use your data frame name dot and then your column name. So column name is age. So it means that take all of the values and the column from the column age. So 40, 45, 30, 34, and 33. And then your while. So pre-hold numbers, which is this, and post is these numbers. And then again, we mentioned the title as a scatter plot. Y label is y-axis, X label is x-axis, and the legend. So you can basically see this over here that, okay, x-axis was your age, y-axis. So for the age is 30. So who is 30 over here for Rosa Diaz? Your arrest numbers initially were around 75, but then it rose to around 120 or 121. And similarly for the rest of the people, you can basically see that there are 5 dots, which is representing 5 different people. And then it shows how that trend has changed. So over here, had we had a constant, downward line starting from here to down, we could very clearly see that, okay, their performance has downgraded over the time after the new captain arrived, right? So since we have no particular thing, we can just see that, okay, all of the newer values, which is the values in blue, almost all of them have improved compared to what their previous values was. So we know that in general, it was a positive effect that was had by the captain. Now, similarly for line plot also, you can do the same thing. So the same type of data we can represent in a line plot, and all it's doing is just connecting the dots. So again, column age, column pre numbers, column age, column post numbers. And then the same thing that we've done is we've labeled it line plot, and then we've shown the trend over here. And yeah, then again for a bar plot, if you just wanted to see, what each person's name was and what their age was, you can simply just access that particular column and that particular age. And yeah, you can just customize your bar plot as is. So yeah, that's basically an overview of Matplotlib for y'all. If y'all just want to explore this further, it's very easy. Since you have all of the information available online, you literally just have to Google Matplotlib documents, and it'll show you all of the information. In fact, even if you're inquisitive and you want to see what goes on behind the function bar, you can even see the actual program that is written behind the function bar. So all of that is available, and yeah, like that's from my side. And yeah, thank you so much for being such a lovely audience. Are there any questions regarding this?
Yeah, I have a question. Suppose we are creating this graphs, these bars for our own personal use, and we want to use this graph. Say, for example, I have a conference paper and I want to use the graph. So how will I use it?
You want to use it in a separate paper or something?
Yeah, I want to use the output. Like you are showing the outputs, right? The bar graphs or anything, and I want to use it for a different purpose. So how to do that?
So one of two ways are there. So y'all I think would be working on Jupyter notebooks, right?
Yeah.
Okay. So what I'm basically using is slightly different. So this is called Visual Studio Code. So Jupyter notebooks are also the same thing. And if you actually go into Jupyter notebooks, you have an option of exporting your entire notebook as a PDF. So meaning that you don't need to, you can use the snip tool and obviously take a screenshot of just this. But at the same time, you can actually export your entire report as a PDF. So rather than taking screenshots, so you have two types of cells, right? You have your code cells, which is, this, where you write your code and execute it. And you have your markdown cells, correct? So you have one of two ways you can do it. So firstly, what you can do is, if you don't want to use Word separately and a programming language separately, whatever text content you can have, you can actually just type the entire thing in markdown cells. Or what you can do is you can just use any, you have something called a snip tool, which is inbuilt in most laptops. You can just take a screenshot of just this, and then you can just copy paste it into any other report that you want. So Python as of now is not yet, that easily supporting exporting just a portion, because this is the output. But yeah, you can just simply take a screenshot of this and copy paste it anywhere.
Okay.
Yeah.
Thank you.
Yeah, no problem. Does anyone else have any queries?
Yes, actually. Yeah, consider I have a corpus, maybe a few million words corpus, and
Sorry, I didn't follow your. Could you repeat that?
yeah, consider that I have a corpus of text or speech corpus, a few million words and a few speech corpus having a few hundreds of durations. Okay.
Okay, okay.
When I have to build something using the corpus, so that other people can access the corpus along with its metadata and work on the statistical functions along with some machine learning techniques and all. How do I go on building that?
So basically, you've built a program and you've built a project, and you want other people to be able to access that, right?
Yes. Yes.
Okay. So you have a platform called GitHub that you all may or may not have heard of. So GitHub is basically a platform that allows you to host your projects online. So you can create an account for free. You just Google GitHub. I'll put it in the chat, the name of this thing.
Okay.
So GitHub is basically the name of a platform. It's kind of like a social media network for programming. And what you can do is you can just create a portfolio. So similarly, how architects and civil engineers have a portfolio of the designs and stuff they've made, you can actually put up your projects. Like you can put the entire Python notebook, you can put the entire code up onto GitHub, and you can make it open source. So people who want to work on that can actually either directly download your code and work on that, or they can request for permission to be able to edit your code. So it's kind of like displaying it to the world. So rather than you having your resume with you, it's kind of like an online resume. So your project, what you can do is you can basically upload it onto GitHub for free, and you can just make it open source and give access to the public. And then anyone and everyone who has that link, so similar to how you share files from your Google Drive using a link, if you make it available to other people, if they know your name of the project, or if they have the link, they can just go onto that link, they can download it, and they can continue working. So that is one place where they can access it. Another thing is a website called Kaggle that I'm sure you all will be familiar with. It's basically a website that is famous for data sets. So here, for instance, we created the data, right? You'll even have sets of data that have been collected over years. Like, okay, I'm working on a project which is regarding wildfire data, which is able to predict the cause of what caused a wildfire in California, in Melbourne, in Sydney, or anywhere. So those data sets are stored online on GitHub, online on Kaggle. So you can just go there and download. So for each of the data sets that's there on Kaggle, I'll put the name of that also. You will have something called notebooks. So similar to this Jupyter notebook that you're seeing, people would have uploaded their work onto that. And even you can upload your work onto there, and people can download it from there. They can download the data set from there, and they can just change it and work on it as and when they want. So these are two websites that are extremely helpful, Kaggle and GitHub, that you can definitely check out. And yeah, both of them are free of cost. In fact, Kaggle even holds, many free data science competitions and programming competitions that you can just take part in to gain more exposure. And yeah, people will review your projects. They'll see how good it is, and they can give you tips and tricks as to how you can make it better.
Okay.
Yeah.
Yes. Thank you.
Any other questions? Sorry.
Hi. So I wanted to actually I have seen some of the graphs which have n-dimensional
I'm really sorry, but I'm not able to hear your voice. You'll have to speak a bit louder.
Okay, sorry. So am I clearly audible now?
Yeah, perfect.
Okay, so I've seen some n-dimensional plotting. So how can I use that?
Okay, so n-dimensional. So here you can see that I've mentioned the x and y axis, right? Yeah, so n-dimensional basically means that are n number of dimensions. So if you mention only x and y, it means two-dimensional. So you have your x-axis and y-axis, right? So if you want to have a three-dimensional figure, you'll have to need the coordinates of the third one as well. So n-dimensional is not something I have personally come across yet. Like, I've not personally worked with, so I wouldn't want to give you the wrong instructions for that. But it is definitely possible. You need the coordinates for your z-axis as well, which is the third axis. And yeah, using Matplotlib also, it's definitely possible to access that. So I can put a few links also in the chat and keep where it, for your different types of styles and stuff that you can actually access. And these will basically tell you how all you can experiment. And even for Matplotlib, there is a separate website that shows what all types of charts and stuff you can put. And yeah, you have YouTube videos which are explaining everything. So like I said, open source. So you literally just have to put it on, Google that, okay, how to make a 3-dimensional plot, and you'll have like millions of videos that are actually showing you how to do the same. So I haven't personally worked with it, so I'd rather not instruct you and give you wrong information. But yeah, 3-dimensional plots is also possible using this. And yeah, you just have to mention, as far as I know, you have to just mention your coordinates of the third dimension and accordingly plot it. So here, for instance, if we have variables x1, y1, you'll put a third variable. So suppose this, I make it z1 or z2 and so on. So as long as you mention the right coordinates, you can definitely plot a 3-dimensional one.
Okay, thank you.
Yeah. Anyone else has any questions? It doesn't have to be particularly about MATLAB. Any general questions also about data science or anything? Okay. So there is a field in, sorry?
Yes, I wanted, actually, you are using Visual Studio, no?
Yes.
So I have also used, it's very comfortable, but I was having problem using Atom. So have you used that?
I tried Atom, but then I wasn't too much of a fan of it. So I switched to PyCharm and then to Visual Studio Code.
Yeah.
So
I faced the same.
Yeah, so what happens is you have two types of software platforms on which you work when it comes to Python, okay? You have something like, so Jupyter Notebooks, Anaconda, Spider, all of these things are what are known as IDEs, Integrated Development Environment. So what an IDE basically does is it makes programming and it makes coding extremely convenient for you. So IDE is basically, Jupyter Notebook, Spider, all of these are IDEs. So what they basically do is you don't have to separately, so over here we saw that, okay, we were just using the import command to access the library Matplotlib, or we were using import command for pandas, for NumPy, and so on. You'll have certain softwares like PyCharm. I think even in Atom, that's the case that, okay, you'll have to physically first install a library and then you will have to use the import command to use it. So what happens is over time, as you work with more and more projects, it can get really inconvenient for you to, each and every time you start a new program, you have to set up a whole environment, a whole system to be able to, work on programming. So when you're starting off, I would recommend, you can work with Jupyter Notebooks, you can work with Spider and these type of softwares, because trust me, they are extremely powerful and there is nothing wrong with the softwares. It's just that as your programs get bigger and more with more sensitive data, I'd recommend switching to Visual Studio Code, which is my personal favorite, or you have something called PyCharm. So all of these, what it does. So over here, if you see when I'm typing, I don't even have to type the entire thing, right? It is giving me suggestions. So if I just type this and press enter, it types the rest for me. So you have options like Visual Studio. So if you had issues with Atom, I would genuinely recommend Visual Studio, but just make sure that before you're installing it, uninstall and remove all of the files that you had related to Python or Anaconda or Atom before. Because what will happen is when you install Visual Studio Code and you already have other files installed, it will get confused between which files to actually use. So yeah, if you've had issues with Atom, Visual Studio Code is definitely an amazing alternative. And yeah, like you have a lot of libraries and a lot of functions that you can put. So for instance, IntelliCode is Visual Studio Code is created by Microsoft. So IntelliCode is basically a plugin which will complete the code for you. So every single time you do not have to type figure. So even if I've already used a variable X or Y before, next time I don't have to type the whole variable name. I just type first few letters and it will show me suggestions of functions, variables, libraries, and everything matching that. So Atom, if you've had issues, definitely switch to Visual Studio Code because you'll find it way more convenient. Atom is good. It's just that it's more of an editor rather than IDE. So a lot of things you'll have to physically install on your own. But yeah, Visual Studio Code, it's more or less all inclusive, so you won't have that many issues.
Okay, thank you.
Yeah, no problem. Any other questions?
Okay, if there are no any other questions, so we can wrap it up and move to that session after in an hour at 3 p.m.
Yeah, sure, definitely. All right, guys. Thank you so much for the session. You were an absolute delight to teach. And yeah, I wish you all the best of luck. And natural language processing is one area which is definitely going to be in the strong suit for you all because you all come from a linguistics background. So definitely go ahead with that. And Professor Totempudi, like Sri Ganesh sir, is someone who's worked in that area for years and years in the past. So he's one of the best people to learn from. And yeah, also thank you to the college to providing the students with such an amazing opportunity. Like the initiative that you all are taking is seriously amazing. There are not that many colleges that are actually conducting, workshops that are relevant to the field and actually preparing us for the industry. So yeah, thank you for that, and yeah, best of luck to all of you all. And if you all have any queries, you all can anyway reach out to me on LinkedIn as well.
Okay, thank you so much. It was very
Yeah. Thank you so much, everyone. Have a nice day.
Bye.